Foundation is one of the most important part of any structure because it transfers the load from superstructure to the soil. At the same time, foundation failures is one of the common root cause for failure of many structures because there are a lot of uncertainties involved with reference to soil. Also, nowadays, we are using complex finite element method-based software applications for solving the problems related to foundation engineering. Also, during the entire project life cycle, effective interface is required between a geotechnical consultant and structural consultant. In line of the same, we are receiving numerous queries for design of foundations. So with these, we are pleased to launch our online course, Foundation Engineering Part 1. Course ID is RCC-STR-003. And we'll be using software SAFE and STAAD Foundation Advanced throughout this course. And mainly, we will be performing design of foundations using Indian standard codes. But let's say if it is required by the participants, then we'll also perform design of few foundations based on ACI 318 using software STAAD Foundation Advanced. Let's see quick highlights of the course. The entire course is divided in 5 different sections. So the section number 1 is finite element analysis of foundations, where we'll be performing FEM analysis using software SAFE and software STAAD Foundation Advanced. Section number 2, understanding the geotechnical and structural interface, wherein we will highlight very important interface areas between geotechnical and structural consultant throughout the project lifecycle. The section number 3 is foundation design using SAFE as per IS 456-2000. So mainly we'll be performing a design of all foundations using Indian standard codes using SAFE software. But let's say if it's requested by the participants, then we'll also perform design of few foundations using ACI 31819 based on STAAD Foundation Advanced. Section number 4 is multiple case studies, wherein we have collated a number of interesting case studies and which will definitely ensure effective learning throughout this course. And we'll be also giving interesting exercises to the participants, which will facilitate discussions on very important areas. And section number 5 will be also talking about enhancing the quality of geotechnical investigation. So what are the important areas that should be covered into the geotechnical investigation report? Let us see how these content of 5 different sections is placed throughout this entire course. So the number of sessions which are mentioned are tentative. So we will increase the number of sessions to cover the content which is mentioned in the brochure. So firstly, we'll start with the understanding of finite element method approach in the software STAAD Foundation Advanced as well as in the SAFE software. So firstly, we will create simple computer models in the software STAAD Foundation Advanced. So we'll be creating rectangular mat, assigning soil supports, creating load combinations, etc., and then performing analysis. And finally, we will derive the pressure and settlement values from the simple models. And those values will be comparing with the manual calculations. And based on that, we'll highlight a few important do's and don'ts for the software application. Thereafter, we will take up the similar simple problems in the software SAFE. Again, we'll follow the same procedure. We'll try to understand step-by-step procedure for modeling the foundation in the SAFE software, like creating the EDEBS file, then how to transfer the load from the EDEBS file, then creating spring, size of meshing, creating load combinations, then performing analysis of the foundation. And finally, the most important part will be performing manual verification of the examples which we have considered in this session. Right? And we'll definitely highlight do's and don'ts for the software application after comparison of the results. We'll be taking similar problems in the STAAD Foundation Advanced as well as in the SAFE software. And then we'll be comparing the results, what we get from the different software. Right? And based on that, we'll be having interesting discussions in this session. In the next session, we will create roughly 37 meter by 37 meter dimension of raft foundation in the software STAAD Foundation Advanced as well as in the SAFE software. And then we will compare the results for what we get from both the software. And of course, we will limit our discussion in this session only up to calculation of pressure and settlement values. In the next session, we'll be touching upon the most important area of the foundation design, and that is the limitation of response spectrum analysis. So I already gave multiple talks on this area, and in the different courses, wherever opportunity or it arises, I highlight this area. So in this course also, we'll be talking about limitations of response spectrum analysis. So one of the major limitation is the algebraic signs are lost. So if we are not taking the appropriate actions, or let's say if we are not modifying the signs for the combined foundations and the raft foundations, then the results could be completely wrong. Right. So that's what we'll be addressing in this session. We'll see the option which is available in the STAAD Pro software with reference to response spectrum analysis. And we'll also talk about the option which is available in the EDAPS, which we must exercise when we are designing our foundations using response spectrum analysis. So after understanding pressure calculation and settlement calculations based on finite element method approach using the software, we'll start talking about interface areas between structural consultant and the geotechnical consultant. So in this session, we'll be highlighting very important areas which must be focused throughout the project life cycle. In the next session, we will initiate our discussion related to a very important area, which is modulus of subgrade reaction. And for this, we are receiving numerous queries like what is the modulus of subgrade reaction, how it is to be calculated if it's not given in the soil investigation report, whether a value of K will be constant for the entire site, or it will change from foundation to foundation. What are the recommendations given in the Indian Standard Code with reference to the modulus of subgrade reaction? What is the interface required with the geotechnical engineer for deriving appropriate value of subgrade modulus of reaction, and many more queries. So that's what we will address in detail. And finally, we'll be talking about the recommended approach for modulus of subgrade reaction. After discussing the important interface areas between geotechnical and structural engineering and modulus of subgrade reaction, etc., so then we'll be talking about important Indian standard codes related to geotechnical investigation. We will have quick overview of important geotechnical investigation related Indian standards like IS 1892 for subsurface investigation for foundations, IS 6403 for determination of bearing capacity of shallow foundations, IS 8009 part 1 and part 2 for calculation of settlements for shallow and deep foundations, IS 1080 for design and construction of shallow foundations, IS 1904 for general requirements for design and construction of foundations in soils. We'll continue our discussions in the next session, wherein we'll be talking about IS 2911, Part 1 for different concrete piles, IS 2950, Design and Construction of raft foundations, IS 11089, Design and Construction of ring foundation, IS 4091, Design and Construction of foundations for transmission line towers, IS 11233, Design and Construction of radar antenna, microwave, and TV tower foundations, IS 13094 for selection of ground improvement techniques for foundation in weak soils. After having discussion about interface between geotechnical and structural engineering, we'll start our discussion related to foundation design with reference to IS 456 for flexure design, one-way shear check, punching shear check, etc. So for that, we'll be generating simple computer models in SAFE software, and wherein we will try to understand methodology of the software. So for example, what is the meaning of strips? What should be ideal width of the strip? Or what's the difference between the software results, what we get based on the strip as well as the FEM based results? So parallelly, we'll be also performing manual calculations so that we can compare the results with the software. And based on that, we'll be highlighting very important do's and don'ts related to foundation design. So after finishing our detailed discussion about software methodology for design of foundations, we'll start our discussions on different interesting case studies. So we'll start with the case study of isolated and combined foundations. So we'll create computer models for isolated and combined foundations in the SAFE software, which is supported on piles as well as which is supported on the soils. And we will perform analysis as well as design of these foundations. And based on that, we will be having interesting discussions. In the next session, we will take up design of octagon foundation, which is supporting vertical vessel of oil and gas industry, which is having height of roughly 20 meter. That will be supported on soil. We'll also consider taller vessel, which will be supported on the piles. Thereafter, we will be talking about modeling of annular raft supporting chimney. So we'll generate one of the computer model for the annular raft supporting chimney, and then we will compare the values of pressure and settlement with reference to the manual calculations. In the next session, as a part of case study, we will take up foundation for 10-meter high retaining wall. And thereafter, we'll take up the case study for foundation of a transmission line tower, which is supported on soil as well as supported on piles. Thereafter, as a part of case study, we will take up raft foundation supported on soil. So we'll talk about values of subgrade modulus reaction, transferring loads from the E-tabs to safe, analyzing the raft foundation, etc. And finally, designing the raft foundation, and then discussing the very important areas based on this entire design cycle. Thereafter, we will take up the raft foundation, which is supported on piles for the tall buildings. So what should be spring values for the piles? Again, transferring loads from E-tabs to safe, analyzing the raft foundation, and then finally performing the design of a raft. In the last session, we'll be talking about a few of the areas which are to be considered for improvement in quality of geotechnical investigation. We'll be also talking about balance queries of the participants. And finally, we'll be talking about concluding remarks and way forward. So looking forward to see you inside this unique online course related to foundation engineering. Thank you.